Yeah, good morning, one and all. So I hope everybody is getting my screen and again voice. And also I have started my video also. So in this lecture also I have enabled the waiting room here, but one of the student Gauri is there who has not given her roll number and again the division. And who is Chaitanya Satish? She has written the XB6 roll number. So what is that? I am not getting here, so I am not allowed her in the meeting. Chaitanya Satish Latke. So kindly enter into the proper name. And others, they have given the very correctly roll number, division, and again the name. Okay. So Gauri and Chaitanya Latke, please try to enter into the room with your proper division, again the roll number and again your name. Okay. So we start our syllabus. So already we have started the substitution techniques here. Just we'll take the review of this one. So what we have covered in the previous lecture, so that we will move towards to our new point. So basic terminology. So already we have studied this basic terminology. So about the plain text and again cipher text. So what is the plain text? What is the cipher text? What is the cipher? Okay, key and cipher, decipher, and again the cryptography, the cryptanalysis, okay, cryptology. So all these points already we have covered. Okay. And there are two kinds of ciphers. So one is the one is the symmetric ciphers and another one is the public key ciphers. So I told you about what is the difference between symmetric ciphers and again public key ciphers. Okay, the public key ciphers is also called as the symmetric cipher. And the major difference between symmetric cipher and again the public cipher is that in the symmetric ciphers, we are using the same key at a sender side as well as the receiver side. But in the public key ciphers, we are using the different keys at the sender side as well as the receiver side here. Okay, so this is the major difference between symmetric ciphers and again the public key ciphers here. Okay. And a symmetric encryption. So already we started the symmetric encryption. So the main definition or the main concept of the symmetric encryption is that sender and recipient share a common key. So both parties have full information of the keys. So the party means what here? So sender is the one party and again the receiver is another party. Okay, in our communication, we are going to consider a sender and a receiver. Okay, but standard form for a sender and receiver for the calling purpose is that the party number one and again the party number two here. So the party number one may be the sender and again the party number two may be the receiver. Okay. So this symmetric encryption we are going to cover into the first chapter. And this symmetric encryption is also called as the private key encryption. Okay. Otherwise, it is also called as the conventional encryption. Okay, so all the names are the same here. You just remember this, all the things. Symmetric encryption is also called as the conventional private key and again the single key. Okay, so all the things you should have to remember this one. So this is the standard model for symmetric cipher, the model here. Okay, so what exactly we are going to do in this the symmetric cipher model here? See, again, I'm going to tell here the symmetric cipher model is that. So you should remember the whatever the secret key is there or whatever the key is there, it is shared between sender and receiver here. Okay, this is the main important aspect of the symmetric cipher model here. Okay, everywhere you will be asked that. So why it is called as the symmetric cipher? So you should know that what is the meaning of a symmetric cipher here. So this is already we have studied this one. What are the requirements? So these requirements also we saw that. So the requirements are nothing but. So you should know this. These are the notations we are going to use. Okay. In this subject, always we are going to use the some important notations here. These notations you should know that. See, whatever we are going to talk using the theoretical, but if I am going to write it in terms of the mathematics, then it is very easy to understand. Okay, so whatever the symmetric ciphers we are going to study, these symmetric ciphers we are going to describe by using these two equations. Okay, y is equal to ek of x and again x is equal to dk of y here. This is very important. You should know what is the meaning of this one. Y is equal to ek of x and again what is the meaning of x is equal to dk of y here. So what is the y here? See, this is related to the sender side. Okay, the first equation is related to the sender side here, and again the second equation is related to the receiver side here. So what is the sender side equation here? Y is equal to ek of x. So what does the sender here? See, the sender is going to calculate the cipher text here. You should know that. Okay, the sender is going to produce the plain text, and from the plain text he is going to convert that plain text into the cipher text. Okay, this is the work of the sender here. So that is why. So the y is nothing but the cipher text. Okay, the y is called here the cipher text is equal to ek of x. So the x is the plain text here. So what the sender is doing here? The sender is going to perform onto the some process onto the x, that is the plain text, along with the key k here. Okay, so that process is nothing but the encryption of x along with the key k here. The key k is nothing but the shared secret key. Okay, this is called as the shared secret key ek of x. Means output of this encryption of this plain text x with the help of the k, we are getting here y here. So the y is called as the cipher text. Means in that way we have to give the meaning of these equations here. Understanding of the equation is very important because in the remaining chapters directly we are going to use the equations there. Okay, so if suppose we are knowing these equations, then definitely we are going to understand the concept here. Okay, so for that purpose, whatever I am going to tell here, what is the plain text, cipher text, encryption, decryption, you should know all the things one. Okay. And again the next, now this is the x. Now you come for the second equation. So what is the second equation here? So the second equation is that the x is equal to dk of y here. Means this equation is the exact reverse of the first equation here. Okay, so what is this equation here? So the capital X is equal to dk of y. So what is the x here? So the x is nothing but the plain text. So why I am telling here, the receiver does the exact reverse process of the encryption, and that process is called as the decryption here. See, the D stands here. So what is the D here? So the D is called as the decryption. So the decryption of Y. So the decryption of Y, the Y is nothing but the ciphertext along with the key K. This K and again this K is same here. Okay. And the receiver will get the plain text is as X here. Okay. So in that way, you should know, you have to identify what is the encryption and again what is the decryption here. So once again, I will tell you that the Y is nothing but a ciphertext. The E is called as the encryption. K is called as the shared secret key. And the X is called as the plain text here. Again, the X is called as the plain text. E is equal to D is called as the decryption. K is nothing but the shared secret key. And the Y is called as the your ciphertext here. Okay. So in that way, you should have to identify what are the equations are there. So the equations are very important here. Now, what is that cryptography? This cryptography also we have studied this one. So we'll see that what is the cryptography here. That cryptography we are knowing this one. Okay. So the types of cryptanalytic attacks. Okay. The what we will do here. So the first of all, we will learn what are the substitution technique, what are the transposition techniques. Okay. So after that, we will see that what are the types of the cryptanalytic attacks here. Okay. So this brute force attack we will see after the completion of our Caesar cipher algorithm. Okay. So these are the classical ciphers. In case of the classical ciphers, we are going to learn the first of all classical substitution ciphers here. I think already one algorithm we have covered in the previous lecture for the substitution cipher. So the name itself indicates that what it is going to indicate, the classical substitution cipher here. So the classical substitution cipher is that whatever the characters of the plain text are there, just it is going to substitute with the another characters. Okay, that's why it is called as the classical substitution ciphers. Okay. Substitute. Suppose the A is there, for the A you can replace the B, C, D like that. Okay, this is called as the substitution ciphers here. Now where letters of plain text are replaced by other letters or by numbers or symbols. Okay. Or if plain text is viewed as a sequence of bits, then substitution involves replacing plain text bit patterns with ciphertext bit patterns. Now this is the Caesar cipher. Already I think we have covered this point in the previous lecture. So this is the very easy algorithm, that is the Caesar cipher. Okay. So at the time of the practical session, you have to implement the algorithm. You have to write the program for a Caesar cipher. Okay. So this is the earliest known substitution cipher. This is the very first Caesar cipher was there, and it is invented by Julius Caesar. Okay, and it is the first attested use in military affairs. Okay, and replaces each letter by a letter 3 places down the alphabet. Okay. So for example, means suppose we have the 26 alphabets here. Okay, you can replace the letters with the 26, but at the somewhere we are getting the same characters here, so you can consider only 25 characters. Okay, because at the 26th character we are getting again the same characters here, so that's why it is not possible for the 26th characters here. Okay, so here also we have the mathematical representation of the Caesar cipher here. So what is the mathematical representation of the Caesar cipher? See, in case of the information and the cyber security subject, the mathematics part is there, and this mathematics part is some part of the mathematics is that the modular arithmetic. So we should know that what is the modular arithmetic. Okay, the mod operation. Okay, So this is the mod operation we are going to see here. So this is the ciphertext equation, and again this is the plain text equation here. So you should know that who is going to see here. So the sender is going to create, or sender is going to produce the plain text, and the sender is going to produce the plain text, and that plain text is converted into the ciphertext. This is done at the sender side. And at the receiver side, so what does the receiver here? So the receiver is going to accept, or the receiver is going to receive the ciphertext here, and that ciphertext is get converted into the plain text again here. Okay. So that's why the two equations are there. So C is equal to E of P is equal to P plus K mod of 26 here. What is the C here? The C is the ciphertext. E is the encryption of P. So the P is called as the plain text. E is equal to P plus K mod 26. And the P is equal to D of C is equal to C minus K mod 26. Okay. So this is the modular arithmetic. Suppose the 1 is equal to 27 mod 26. So I will tell you what is the mod here. The mod is nothing but the modular arithmetic. So what is that modular arithmetic here? If I divide 26 by 27, then how much the remainder? The remainder is going to have the 1 here. Again here the 26 by 29. So here the 3 will get as the remainder value here. Okay. So you can see that the remainder value we are going to consider for the modular arithmetic here. Okay. So this is the very simple, very simple Caesar cipher is there. And the drawback of this Caesar cipher is that it is very simple. Okay. So anybody can see this algorithm and he can implement it. Okay, but it doesn't provide the more security if we are going to use the Caesar cipher. Okay, in the computer world, we are not using the Caesar cipher anywhere, because it is the very easy. Anybody can hack it, and they will get the original plain text here. Okay, and the one more attack is that the brute force attack. So where is the brute force attack was here? What is this brute force attack here? So here I can tell you that brute force attack. So what happened in case of the brute force attack? See, how many 26 alphabets are there? I mean the 26 possible keys are there. So the shift keys are k is equal to 0 to 25 slots are there. Means if I don't know the any key, what the key are using for the converting the plain text to the ciphertext. Suppose as a third person, I don't know what is that exactly key they have used for the conversion of the ciphertext here. So what I will do there, I will first of all I will put the value of the k is equal to 0. I will check the meaning of that ciphertext. Again I will increase for the 1. Again I will check the meaning of that ciphertext. Again I will keep the 2 here. Again I will go for the 3, 4, 5 up to the 25. Somewhere I will get the original plain text there. So what I am doing here, the every shift key k I am going to use for that ciphertext here. So somewhere I am getting the original plain text there. So this is nothing but your brute force attack. Every possible combination we need to apply there, and definitely we are getting the one as the correct answer here. So this is called as the brute force attack here. Okay. Now here also I want to give this one. See here the one example, it is given that test break ciphertext. So this is the ciphertext is there. GC, UA, VQ, DT, GCM. So what will be the plain text for this one? Suppose you don't know the value of the k here. It may be the 0, it may be the 1, 2 up to the 25. But if you are going to keep this one, definitely you will be getting one correct meaning of that is called as the plain text here. Okay. So you can try at your level. That is the GC, UA, PQ, DT, GCM. Okay. So this is the Caesar cipher technique is there. So at the time of the practical, once again I'm going to explain this one, and you have to perform the you have to perform this. You have to write the program for this. Okay. Now the monoalphabetic cipher. So what is the mono-alphabetic cipher here? See, again, the name itself indicates that what is the mono-alphabetic cipher. So what is the meaning of the mono-alphabetic? So the mono-alphabetic is that only single alphabet. Mono means what here? Single. Alphabetic means alphabet. What characters? Okay. The single character we are going to use here. Okay. This is called as the. This is very easy again. Okay. Whatever this algorithm is there, this algorithm is the very easy here. So what is here? Here you can see that rather than just shifting the alphabet, okay, what we have shifted in the previous Caesar cipher, we have shifted the alphabets, okay. But here in shifting, one more addition we are going to perform here. Could shuffle the letters arbitrarily. Very important. See, whatever the letters are there, these letters we are going to shuffle it arbitrarily. Arbitrarily means there is no any proper sequences we are going to follow here. Okay, in Marathi, you can say that arbitrarily means swatantra. Means we don't have the any proper sequence. Everywhere of the any characters, we can shuffle it at any location or at any position here. Okay, it could shuffle the letters arbitrarily. And each plain text letter maps, okay, each plain text letter maps to a different random ciphertext letter. Okay, different random ciphertext letter here. Is what is the how it is going to perform the monoalphabetic cipher here. So the each plain text letter maps to a different random ciphertext letter. So we'll see that how it is going to perform. Hence the key is 26 letters long here. Means what we are going to consider here, whatever the 26 alphabets are there, these 26 alphabets we are going to make one arrangement. The arbitrarily arrangement, we are going to consider the any character at the initial, suppose Z, M, L, whatever it may be. These 26 letters we are going to consider here, and these letters we are going to have one key which is length is equal to 26 here. Now here you can see that how we are going to perform the encryption and again the decryption by using the monoalphabetic cipher here. Now here the plain text is there, and again here the cipher text is there. So what is the plain text here? So the plain text is from the A, B, C, D up to the Z. Okay. And again the cipher text we got here. So what is the cipher text here? The cipher text we are going to consider D, K, V, Q, F up to the N here. Okay. Now we have this cipher text, and from that cipher text again we are going to calculate what is the cipher text here. See how we are going to calculate the plain text here. So if we wish to replace letters, so this is the plain text here. So what is the plain text here? If we wish to replace letters here. Now from this plain text we are going to calculate the cipher text here. So how we are going to calculate the cipher text here? Now here you can see that the plain text letters are here, and again these are the cipher text letters are there. Now here you can search the plain text. The I is there first of all. So in the plain text we are going to consider the I here. So this is the I. Okay. So I will use the annotator. So this is the I here. So have you got this? This is the I. And what is the corresponding letter for the I in the cipher text row here? So in the cipher text row, I got this W. Okay. Here you can see that for the I, there is a W there. So the cipher text character will be the W here. Okay. The similar way again, the F is there. So what is the F? You need to search into the plain text row here. So where is the F here? So F is here. And what is the corresponding letter into the cipher row here? For the F, we have the I here. Okay. So this is the I is there. This W is over now, and this is the I. Now the next one is what is the plain text letter is the W here. So we have to search the where is the W letter into the plain text here. So this is the W, and what is the corresponding letter to the ciphertext here? R here. So here we got the R here. Again, the next one is the E is there. We need to search out in the E. So here is the E, and this E we are going to consider the corresponding letter for the cipher is F. So here we got the F here. Again, the next one is the W. Again, the W we got the R here. Okay. Again, the I is there. For the I we got the W. Now the S is there. So where is the S? So S is here. So what is the corresponding letter to this one? A here. So here we got the A here. Means in that way we can identify what are the ciphertext characters here. See, this algorithm again, it is the very easy. Nothing in this one. We need to arrange the plaintext characters, and again we need to arrange the ciphertext characters. But what is the drawback of this monoalphabetic cipher here? Can you tell me? What is the disadvantage of this one? See, the disadvantage of this one is that so what is the disadvantage? Now here you can see that whatever the same letters are there, they are repeating their same characters of the same alphabets here. Now here you can see that I is there, I. So I again the W is there. For the next I again W is there. Okay. Again you can see that again for the W R is there. Again for the W R is there. Okay. Now you can take the E. For the E F is there. Again for the E F is there. Again for the E F is there. Again for the E F. Again for the E F. So the what hacker will do here? The hacker will replace or identify which are the frequently occurring characters are there, and he will be try to replace the original letters there, so that he will get the plain text there. Means this algorithm also doesn't work or doesn't provide the more security to our information here. This is also having the some drawbacks here. Now in the English literature you can see that everywhere we are going to use the and, again the again the E letter. Okay, again the A letter. So these are the frequently occurring characters are there. For them, this algorithm is very it is not useful for these frequently occurring letters here. Okay, that's why the monoalphabetic cipher also doesn't provide the more security. Okay, so now have a total of 26 factorial, that is 4 into 10 to 26 keys are there. And with so many keys, you might think is secure, but the simplicity and strength of the monoalphabetic substitution cipher dominated for the first millennium AD, but would be wrong. First broken by Arabic scientists. See, in the 9th century, it is broken by the Arabic scientists. Now you can imagine this one. Okay. But more is that one more advantage of this algorithm is that we can have these multiple keys here, 4 into 10 raised to 26. With the 26 factorial, you can in 26 factorial. Okay. So in that way, you can use we can arrange the key here using the 26 alphabets. Okay, that is possible. But it doesn't provide the more security. Okay, this is the frequency analysis. So what I told you that, so letters are not equally commonly used. In English, E is by far the most common letter. Okay. Then T, R, N, I, O, A, S. Other letters are fairly rare. Okay. So fairly rare letters are Z, J, K, Q, X. Okay. And have tables of single, again the double, and again the triple letters here. Okay. So this is the graph of the English letter frequencies. This here you can see that these are the vertically we are going to present this horizontal. We are going to present these letters from the A, B, C, D to up to the Z, and this is the relative frequency occurring into the English literature. So the E is having the highest literature. Highest occurrence is 12.702. Again, after that, we have the T. Again, we have the O, I. But this is that way we can have. We just take this diagram here. So this is the very important. So this is about the English letter frequencies, which are useful for the monoalphabetic cipher. So using the cryptanalysis. So the meaning of the cryptanalysis is that as a third person or the hacker is going to try to find out the plain text from the cipher text without knowing the key here. Okay. So the key concept, monoalphabetic substitution ciphers do not change relative letter frequencies, and it is discovered by Arabian scientists in 9th century. Calculate letter frequencies for cipher text, compare counts, and again the plots against known values. And for monoalphabetic, okay, and it is calculate letter frequencies for cipher text and it is compare counts of the plots against known values. For monoalphabetic, must identify each letter. Tables of common double, triple letters help. So this is about the cryptanalysis. Now this is one example of the cryptanalysis. So we just it's very easy example is there. So this is the given ciphertext, and we need to find out what will be the plain text of this one. So the plain text is identified here. This is the given ciphertext, and count relative letter frequencies. Guess P and Z are E and T. So proceeding with trial and error, finally get. It was disclosed yesterday that several informal but direct contacts have been made with political representatives of the Viet Congress in Moscow. Okay, this is the ciphertext. Anybody can hack it. Okay, this is the very easy algorithm, nothing in that. Now the Playfair cipher, the very important algorithm, Playfair cipher. We'll see that what is the Playfair cipher here. The Playfair cipher is the very important algorithm. Okay. Again, we have the polyalphabetic cipher. Again, the polyalphabetic is also called as the visionary cipher. Okay. And next one is the one-time pad. See what we'll do here for the Playfair cipher, and again for visionary cipher, we require one full 1 hour. So the both algorithms we can study in the next lecture. But before that, we will see what is the one-time pad here. See the one-time pad, this is the very easiest algorithm. So what we are going to do here in this case, one-time pad. Okay. So whatever these remaining two algorithms are there, tomorrow in the next lecture I will explain, because it requires the more time for explaining. That is polyalphabetic cipher and again the Playfair cipher. Okay. Now we'll see that what is the one-time pad here. So if a truly random key, as long as the message is used, the cipher will be secure. Okay. And it is called a one-time pad. So what it suggests there, you can choose a ciphertext character as one random key here. Okay. As long as the message. Okay. And it is called a one-time pad. And it is unbreakable since ciphertext bears no statistical relationship to the plain text here. And no repetition of patterns. Since for any plain text and any ciphertext, there exists a key mapping one to other. And it can only use the key once, though have problem of safe distribution of key here. Means in case of the one-time pad, we have to apply the the key as long as the ciphertext here. Okay, so that we'll see what is that one-time pad here. 1 minute. Just a minute. I'm not getting that online tutorial. Yes, I will open the notepad. So here I will give the example of that one-time pad. So how the one-time pad here, how it works. So this is the one-time pad. So again, I will increase the font here so that so this is the one-time pad. So the plain text we can take here. Okay, so what is the plain text here? Plain text you can take. I am in college. Okay. So here the keyword we need to choose. So what is the keyword here? So any keyword we can take. Suppose the keyword will be the any keyword we can take. For example, the keyword is that. Suppose the school. SCHOOL. Okay. Now from that we need to create the plain text characters and again the ciphertext character. So here I can write the plain text character, and again here I will write the first of all I will write the keyword characters. Okay, and continuously I am going to write here I am in college here. Now my plain text is going to end here. Now here I want to write the school here with the key school. SCHOOL. Now how many characters remain again? 1, 2, 3, 4, 5, 6. Again I'm going to repeat my same keyword here. SCHOOL here. Okay. Now suppose again the one more letter is there at in the plain text. Now here again I'm going to increase. Again the two letters are there. Again I will repeat the my key K here. Again I will start with the SC. Now it is going to end here. Okay. Means in that way we need to consider the plain text characters here. Okay. So that you will be getting the ciphertext here. So how the ciphertext we are going to calculate here? For the ciphertext, so by using this P and K combination, we are going to consider the ciphertext, the characters here. So this is called as the one-time pad here. Okay. So this is the meaning of the one-time pad. Okay. Here you can see the once again. The one-time pad is nothing but if a truly random key, as long as the message is used, the cipher will be secure. And it is called a one-time pad. And it is unbreakable since ciphertext bears no statistical relationship to the plain text. So there is no question of the repetition of patterns. And since for any plain text and any ciphertext, there exists a key mapping one to other, and it can only use the key once though have problem of safe distribution of key here. Okay. So this is about the one-time pad. The I think this is the time is over here. So the remaining two very much important algorithms we'll see in the tomorrow's lecture. Okay. So these are the remaining, whatever the remaining two algorithms are there, these are the very much important for understanding purpose also and for implementation also. Okay. That is a Playfair cipher and again a polyalphabetic cipher. Okay. So here I'm going to enable the chat room here. So anybody is having the any problem or the any doubt, just you can ask here. Is there any doubt or any problem? Just I enable the chat window here. I request you all, please have the any doubt or the any problem, please mention in the chat window. I am waiting for your replies. If you don't have the any doubt here, so I request you all, please mark your attendance with your roll number and again the name. Only once you drop your roll number, don't repeat again and again here.